Hey, welcome back. Um, Last time we were talking about the equations of a line as a vector function involving the writing down the components as and being able to read off the a point on the line and the direction of the line as the coefficients of t. Um, what we're going to talk about now is learning how to use these lines and work with them. And so let's first talk about if you're in two dimensions, your lines can either be parallel or they can intersect. But in three dimensions, your lines can still be parallel, right? So what would that mean to be parallel? It means they have the same direction. But if they don't have the same direction, they can either intersect or one can pass over the other and they can just never meet. So let's work and see if we can characterize that. So let's do first an example. Find the equation of the line that goes through these 2 points. So to go through 2 points, right, we can write this down in, so when you want to find the equation of a line, you need to have a point and a direction. So what are our points and what are our directions? So we can write this as, so our point, we can just choose any of them, 2, 4, -3. And a direction, we have to take the difference between the two points. So 3, -1, 1, -2, 4, -3 gives us a direction of 1. -1 minus 4 is -5. 1 minus -3 is 4. And so the equation of the line would be, remember this is a parametric equation, so we need to have an x, we need to have a y, we need to have a z. And so x of t would be 2 plus 1t. Y of t is 4 minus 5t. And z is -3 plus 4t. And remember what we're doing is we're reading off. This is the coefficient 2 for -3. And then this 1, 5, 4, 1, -5, 4 are these coefficients are the components of the direction of the vector. And as we mentioned before, you could have also written this in using the linear interpolation method, where we could say, okay, x of t is equal to 1 minus t times 2 plus 3 times t. Y of t is equal to 1 minus t times 4 minus 1 times t, and z of t is equal to 1 minus t times -3 plus 1 times t. And if you go in and you simplify those, you get the exact same equations. All right, so here's a question. Where does this line pass through the xy plane? So we have an equation of our line. Let's see if I can copy it and paste it. Is that allowed? Copy. So where does this pass through the xy plane? Well, what does that mean? We have to interpret that. Where does the line pass through the xy plane? Well, if it passes through the xy plane, it means that the equation has a z-coordinate equal to 0. So in other words, so let's see if I can paste this. So in other words, what we want to do is find where z of t is equal to 0. Because we need to have, if you're in the xy plane, the z-coordinate is 0. So we're going to find where the z of t is equal to 0. So negative 3 plus 4t is equal to 0. Solve for t. And when we do that, we get that t is equal to 3/4. So plug in into the equation. All right, so x is equal to 2 plus 3/4. Y is equal to 4 minus 5 times 3/4. And z is equal to negative 3 plus 4 times 3/4, which we already knew that was 0. But the x-coordinate is 2 3/4, or we can write that as 11/4. And 15/4 is almost 16/4. So y is equal to 1/4. Oops, x. So this is equal to x. And so the coordinates of where this point goes through the xy plane is 11/4, 1/4, 0. All right. So we were talking about lines being parallel, intersecting, or neither. Neither is called skew. So here are two different lines. Remember, these, you can see that these are lines because they have the form constant plus constant t, constant plus constant t, constant plus constant t. So we know that in both of these cases, these are both lines. So in order to show that the lines are skew, we have to do two things. We first have to show they're not parallel, and then we have to show that they don't intersect. So if the lines are parallel, then what would we know about parallel lines? We know that the vector, the direction in which they go, would be, those two things would be parallel, and so they would be multiples of each other. So they would have the same, maybe put same in the quotes, the same direction, or in other words, the vectors, their direction vectors, are scalar multiples of each other. Okay, so we need to then read off what the scalar vectors are, the scalar multiples are of the two pieces. So we have to read off the direction vectors. So remember, we read off the direction vectors by looking at the coefficients. So the direction vector here, the direction vector is going to be 1, 3, -1. We're reading off the coefficients of the t's. In the second vector, the direction vector is 2, 1, 4. 2, 1, 4. So, are those multiples of each other? So, if they were multiples of each other, there would be one number that if you multiplied it by the first one, you would get the second one. So, is that number 2? Like our best guess might be we need to know what multiple takes 1 to 2. We multiply by 2, but then 3 would have to multiply by 1 by 2 to get 1, but it doesn't. 3 times 2 is 6. So they are not multiples of each other. So they're not parallel. All right, so if they're not multiples, so they're not parallel. And then we want to show that they don't intersect. So how would you know if things intersect? There would be a point in common. So we have this equation for this line, an equation for this line. There would have to be a point that's equal. So set the components, the x, y, and z components equal, and solve for the value of t and s that makes both equations true. So in some problems, for example, in the web work, you may get two equations and they have the same t. They have this as a function of t and this as a function of t. They may be, the parameter may be the same variable. In that case, it's really important that you write one as a parameter t and the other as a parameter s, because we don't need the t value to be equal to the s value. The lines can intersect at any s and t, but here we're already set up to make this work. So we want to solve 1 plus t equals 2s. Negative 2 plus 3t is equal to 3 plus s. And 4 minus t is equal to negative 3 plus 4s. So let's add the first equation to the last equation. What do we get? We get 5 equals, so if 5 equals negative 3 plus 6s. So if both of these two equations hold, then then 5 is equal to negative 3 plus 6s, which means that 8 is equal to 6s. So if 8 is equal to 6s, then s is equal to 4/3. And so in the first two equations, if both first two equations are true, s is equal to 4/3, and what that means is that we can plug that in here and we can get that 1 plus t is equal to 8/3. So t is equal to 5/3. So if both equations hold, then s is equal to 4/3 and t is equal to 5/3. And so the way to see if this works or not is to plug these numbers into the second equation that we didn't use yet. So let's do that. If we plug these numbers into the second equation, what do we get? We get negative 2 plus 3 times 5/3, it's 5, is equal to 3 plus 4/3. Is this true? No, not true. So there is no t, and s pair that satisfies all three equations. And so there's no pair that satisfies all three equations, which means that the lines don't intersect. And are therefore skew. All right, so we've now given two examples of working with lines. Let's stop here. The next video is going to be about planes. All right, see you soon.